Hello friends, most welcome to eCivilTech. Today we are going to solve some of the warnings that may happen to you while making the model. So these are the warnings for which we are going to find out the solution in this video. Let me tell you something about this model. This model is actually done by some of my friends' students, and after making this model they were facing some of the problem in warnings. So let us first find out what are the warnings in this model. We will go to analyze and directly click on run analysis. So total 361 warnings and one note is there. So what we are going to do is we'll go to view output file and click on done. Now these are the warning. This is first type of warning property for member. This is duplicated last value used. Okay, then again warning member 29 are between the same joint, and this is the second type of warning. And then axial compressive stress and the EULER stress for the member. And then finally some member size have changed since the last analysis. Total 4 type of warning we can see over here. Now first we will check for this property for the member 13 duplicated last value used. Now for this what we'll do is we will go into input file Staad editor, and then we will go to property. So here you can see member property Indian. Double click on this. Now here you can see 5 to 7, 17 to 13, then 8 to 10, 13 and 20. This is one property which is covering this member number 13. Again here you can see 16 to 11 to 16. Now what I'm going to do is remove this 13 from here. It is actually this 13 was repeating in this, and this also 16 to 11 to 16. So what I did is I removed from this property. Now I will just save it and close it. Now again we will run analysis to check if the same warning persists. We'll go to view output file and then click on warning, and now you can see that warning is no more. That warning is resolved. Now we will check this second type of warning. Warning members are between the same joints. Now we will check for member 29 and 20. Now come to modeling, and here in geometry, in beams, member number 20, member number 20 is here. Okay, and member number 29 is also here. Let me select this member and Alt VV, and now I'm going to use this option to zoom it. Click Shift B. Now you can see this is your member number 20. Here member number 20 and 29. So what warning says is two members are between the same joints. So we will have to delete one member from here. So what we are going to do is we'll come back to the screen. Click Shift B to remove the beam number. Now what we are going to do is we'll go to tools and then check for duplicate members. Now you can see these 20 and 29 are the duplicate member. Now click on merge. Whenever you will click on merge, it will ask which member to be merged. You choose any one of these and say click OK, and then it will merge into the single member. Then same to be done for the remaining member. While choosing the member, keep in mind that you have to go back to the model and check that particular member is having correct property. If it is not having correct property, then apply the correct property. So what I'm going to do is merge each and every member one by one. What you have to do is choose any of the member and click OK. Then again select merge, let it be 22 and OK. Select merge, OK. So this I'm going to repeat for every member to merge it. Okay, now we are done with merging. Now let's again go to analyze and check whether we get rid of that warning or not. Go to your output file, click done, and then in warnings. Now in this warning page you can see that previous warning, the warning stating the member between the same joints has been taken care of now, and now we will go for the axial compression force. Now what this warning says is the axial compressive stress exceeds the Euler stress for the member phi, and this repeats for many members. Now we are going to check its load, because its load is very used. Only whenever the load is very huge on any member, then only this warning comes. Now we are going to check its load. I don't know what load they have applied, so I'm going to this load. So this load is self weight, then again live load. So they have used some 8850 lb per inch. Okay, so we don't understand this lb per inch, this pound per inch. Actually we understand in kg, in kilonewton, but we don't understand lb in India. Okay, so what I'm going to do is I will check what is the actual value of this lb per inch in kilonewton or in kg. So for that, what I can do is I can go to these tools and then unit converter. Here in unit converter we can go to force per unit, because this is a member load, so force per unit. And here input load is in lb per inch, and what we want is kilonewton per meter. Okay, now the total value is 8850. So now you can see this 1549 kilonewton per meter. Okay, 0.75 I think. Okay, so it is 1550 kilonewton, which is actually very huge. 1550 kilonewton, that means 155 ton. Now we'll close this calculator. There is one more way to check this value in kilonewton. We can change the unit into kilonewton per meter. To change the input unit into kilonewton per meter, what we are going to do is we will first go to setup. Keep in mind, whenever changing the unit, every time you make practice to come in setup, and then click on input units, then we want in meter and kilonewton, and then say OK. Now again go to general, loads, and then here you can see the live load is 1550 kilonewton. It is very huge actually. I don't know why they have used it, but I will just delete this. Okay, and what live load we are going to use is 100 kg. Let us assume 3 men are going up on the tower for some maintenance purpose, and on the higher side I will consider that one man weighs 100 kg. So I will type minus 1 kilonewton and then add and close. Okay, now I will select this load and use cursor to assign. Click on assign and then click on the upper node. Now this is again I am applying more loads. Okay, and then we will check wind load also. Here we can see the wind load they have applied is in both the direction, I think in X direction and Z direction, which is again wrong. When if you go to top view of this structure, we can see that they have applied in Z direction and X direction. So it is not the correct way to apply a load on triangular tower. But first I would like to check their wind pressure. We'll go to wind definition and double click on this intensity. Now this intensity is about 0.61, that is 61 kg per square meter. Okay, so this seems to be fine, no problem in this. Instead of applying this load, wind load in both the side, I will apply from Z direction, positive Z direction. Okay, and that will take care of all loads. So what I'm going to do is I will delete one of this and double click on this, and what I'm going to do is I will choose Z face and change. Now you can see load has been applied only on the tower. Okay, so what I'm gonna do is I will check its value. it is about minus 14.77 meter. Okay, and okay, minus 14.77 meter is the Z value. So here I will apply minus 15 and say change. Here we will choose open structure because this structure is open. So this is very important when you are doing a frame structure which is not covered by any sheet. Then you have to use this open structure because your wind is going to be applied on the members only. If you will not check this box, that means software will consider that structure as a closed structure. Software will consider that you are using any sheet on the structure to cover it, and henceforth it will take the complete windage area. So here what I am going to use open structure. Okay, what I did a mistake here, minimum will be minus 15 and then change it. Okay, now from the top we can see this load is applied on these two cable and this face. This is the most critical wind that can become on the triangular tower. Okay, I will close this. Now we will run analysis and we will check if that warning is there or we are get rid of that warning. See, there is only one warning left. Come to this Staad output, and in the warning page we can see some member size has changed in the since last analysis. Now let us check what he have done in the analysis and design. Come to this design, and now here we can see they have done something here, but what I will prefer to delete this all. So we are designing it by Indian code IS 800. So what we are going to do is we'll define some property. FYLD is 2500. Okay, you can add and close. Assign to view, and then command check code, add, close, assign to view. Now we will again go to run analysis, and here you can see that there is 0 error and 0 warning and 1 note is left. Let us check what note is saying. View output file. Okay, the note is saying if any floor diaphragm is present in the model, wind load definition should be defined. So there is no diaphragm we are considering in this model. So this is okay. This is this note we can actually ignore. I will explain what is this floor diaphragm when I will do the RCC building. So let us close this. So we are clear with the warnings, but still this this entire model is not correct because they have not used any specification. So as I taught you in the previous ground-based telecommunication tower series, that you have to use this release, okay, for the each member, and then you have to apply cable property for the